Good morning, students. Welcome to MS Model School online classes. I hope you have done the previous exercise. I'm taking some more questions from exercise 1.1. Let's start from very beginning. Your question is, so that every positive integer is of the form 2q and that every positive odd integer is of the form 2q minus 1 where q is some integer. I have told you about integers. What are integers? इंटीजर्स हमारे पास इस फॉर्म के थे, माइनस साइड से स्टार्ट होके -4, -3, -2, -1, 0, 1, 2, 3, 4 and so on. These are integers. Where q is some integer. If I am taking q1, what will be the value of 2q? 2 multiplied by 1. If I am taking q is equal to 2, then what will be the value of 2q? Let's try. What is this form 2q? If I am taking q, if q is equal to 1, then 2q will be 2 multiplied by 1. It is 2. When q is 2, then 2q will be 2 multiplied by 2, that is 4. We are looking that this pattern will provide us even integers. Let's try once for negative integers. Q is equal to -3. Then what will be the value of 2q? 2q is 2 multiplied by -3, that is -6. Now show that every positive, this number, positive number, even integer is of the form where q is some integer. We are taking positive integers only, so no need to put up negative values. Let's try some other form as well. What is 2q plus 1 form? Let's start from taking q as positive integers. Positive integers were 1, 2, 3, 4 and so on. So let's try. Now q is equal to, I am taking q is equal to 4. Then can you find out value of 2q plus 1? Certainly 2q plus 1 will be 2 multiplied by 4 plus 1, that is 9, which is odd. If I am taking q is equal to 7, then 2q plus 1 is 2 multiplied by 7 plus 1, that is 15, which is also odd. So certainly these two forms, 2q provides us only even integers. 2q plus 1 are odd integers. The question is how to prove. In order to prove these two forms, that they are even and odd, we need Euclid's division lemma. In previous lesson, I have taught you about division lemma. Do you remember what it was? If yes, then I can remind once again. For any two positive integers a and b, where a is greater than b, there exists a unique relation satisfying this relation. A is equal to b into q plus r. I hope you understand this relation. This is called Euclid's division lemma. Division lemma. यूक्लिड्स डिवीजन लेमा में हमने देखा था, मैंने 35 को 7 से डिवाइड किया था तो यहाँ रिमाइंडर 0 आया था। 36 को मैंने डिवाइड किया था तो रिमाइंडर 1 आया था। वहाँ उस स्थिति में मैं देख रहा था साथ साथ 5 से डिवाइड करता तो रिमाइंडर 4 तक आता था, 7 से डिवाइड किया तो रिमाइंडर 6 तक आ रहा था। यहाँ एक शर्त आपने रखी थी, where r is greater than or equal to 0 and less than b, the divisor। जिस चीज से आपने डिवाइड किया था उससे छोटा होना चाहिए। Are there some other forms? This question is same as previous one. So if I am taking a series 2q and 2q plus 1, all numbers will appear as even numbers, and in this series all the numbers are odd. Now let's start how to prove this. Let any two positive integers a and b, then what is b? Here b is this, b is 2, where b is equal to हमारे पास दो पॉजिटिव इंटीजर्स हैं, एक a है एक b है। b की वैल्यू यहाँ स्पेसिफाई है ऑलरेडी, सो आई हैव टेकन इट एज 2। So can you apply this division lemma for a and b? If yes, then apply it. Applying Euclid's division lemma, what will be the result? I have to divide a by b, that is 2. I have taken this value as 2. Let there be some quotient q and remainder r. So what should be the value of this a? A should be equal to 2 multiplied by q plus r. This is the previous relation I have shown you in Euclid's division lemma. This is just like checking division sum. Dividend is equal to divisor multiplied by quotient plus remainder. Do you remember? If not, let's remind once again. ये हमारे पास था dividend is equal to divisor multiplied by quotient plus remainder. हमारे पास यहाँ डिविडेंड क्या था, ए, हमें ए को डिवाइड करना था, किससे हमने डिवाइड किया, बी की वैल्यू 2 थी। क्वोशिएंट हमारा क्या आया, आई हैव टेकन इट एज क्यू। रिमाइंडर हमारा क्या आया, आई एम नॉट सर्टेन अबाउट आर, so I am taking it R. There was a condition that R should be greater than or equal to 0 and less than B, and B is 2 here, less than 2. So there are possible values of R now. R can have, R is equal to 0, or what can R have value equal to 2? No, there is restriction. यहाँ आप देखें इसमें एक रिस्ट्रिक्शन है, वैल्यू ऑफ आर इज लेस देन 2, नॉट 2, as I am dividing the number by 2. Then you have to substitute this r from 0 and from 1, replace this r. So a will be, our a will be equal to 2 multiplied by q plus 0, or 2q plus 1. Now you can check, this form of a is divisible by 2, and this form of a is not divisible by 2. If 2q is divisible by 2, we can call these numbers even. Now 2q is even number as it is divisible by 2, and the remaining numbers are odd. What are the remaining numbers? 2q plus 1. Remaining numbers are odd, means 2q plus 1, numbers of the form 2q plus 1 are odd numbers. Let's take some more examples. In this question, 2 has been omitted and a new number is placed. यहाँ हमारे पास आप देख रहे हैं 2q था, यहाँ भी 2q था, अब की बार हमारा जो b की वैल्यू है वो 4 है। इसमें कौन कौन सी फॉर्म्स बन पाएंगी? यदि हम किसी संख्या को 4 से डिवाइड करते हैं तो 4 से डिवाइड करने में हमारे पास रिमाइंडर 0 आ सकता है, 1 आ सकता है, 2, 3, 4 नहीं आएगा। Let's try some examples. I am taking 4 to 5 series of a number. Let's start with 70, 71, 72, 73, 74, 75. I'm taking these examples only to make you understand the process. This is not the way you can solve this question. Let's understand this process first. If I try to divide this 70 by 4, what will happen? Let's see. 4 1 is 4, 4 7 is 28, and the remainder is 2. Let's try 71 divided by 4. So it will become 4 7 is 28, and your remainder will be 3. What's about 72? If I divide 72 by 4, 7 1 is 7, 4 1 is 4, 3, 2, 4 8, and remainder is 0. What's about 73? When I divide it by 4, certainly the remainder will be 1. And here comes 18. What is the pattern? There is a pattern in remainder. Look at the remainder. The remainder can have value equal to 0, 1, 2, 3. No remainder is 4. You can try some more numbers. Either the remainder of the form 0 or 1 or 2 or 3 for any number. Let's try 74. Then remainder will be 2. Here remainder will be 3. And next 76 is exactly divisible by 4. So every fourth number is exactly divisible by 4. This number shows that value of b is 4. So it's clear that I will take b is equal to 2. Oh, sorry, 4. Let's start how to solve this question properly on your sheet. I'm starting this question. You have to write your numbers of the form when we divide some integer by 4. Let any two positive integers a and 4. I'm writing value of b here directly. Applying Euclid's division lemma. What will you get? If I divide this a by a number 4, then there will be some quotient q and remainder r. And certainly I have told you that r can have value of 0, 1, 2 and 3 only, less than 4. So a is equal to 4q plus r, where sorry, where r is greater than or equal to 0 and certainly it should be less than 4. This is important term. You have to learn it properly. So what will be the form of this a? A can have 4 different values. A can be written as 4q, where r is 0, 4q plus 1, when r is equal to 1, 4q plus 2, and 4q plus 3. What is your observation now? Take these two numbers first. Do you see any similarity between these two numbers? Yes, these are exactly divisible by 2. And if these are exactly divisible by 2, then these two numbers are even. So certainly the remaining will be odd. You have to write down your statement here. Your statement have to be shown clearly now. And I'm taking space here. I have taken form of A. A हमारे पास था 4q, 4q plus 1, 4q plus 2 and 4q plus 3. Check this number and this number. You have to state separately that 4q and 4q plus 2 are even numbers as they are divisible by 2. Look at this number. Look at this number. These two numbers are exactly divisible by 2. That's why they are even. Therefore, the remaining numbers. What are remaining numbers here? Remaining numbers 4q plus 1 and 4q plus 3 are odd numbers. As positive integers can either be even or odd. इवन और ऑड में जब हम डिवीजन करते हैं तो कोई भी सेट हम नंबर्स का लें तो उनमें कुछ नंबर्स इवन यदि हम निकाल दें तो बाकी रिमेनिंग ऑड नंबर्स ही बचेंगे. लेट्स सी नेक्स्ट क्वेश्चन. This question is of the same type, exactly same type. I'm taking only solution now. Let's try it. Show that any positive odd integer is of the form 6q plus 1, 6q plus 3 and 6q plus 5. मैंने आपको बताया था किसी नंबर को यदि हम किसी भी नंबर को I am taking the same number a here, and if I try to divide it by 6, there will be some quotient q, and remainders can have value of 0, 1, 2, 3, 4 and 5 only. It should be clear. आपके दिमाग में ये बात बिल्कुल बैठ जानी चाहिए कि जब हम किसी संख्या को 6 से डिवाइड करते हैं तो हमारे रिमाइंडर्स की फॉर्म 6 ही रिमाइंडर पॉसिबल हो सकते हैं इंक्लूडिंग 0. क्या रिमाइंडर 6 हो सकता है? नो. कौन सी कंडीशन थी? r की वैल्यू 0 या 0 से बड़ी हो. आई हैव टेकन 0 एंड it should be less than 6, not equal to. So less than 6 numbers are 1, 2, 3, 4 and 5. I think it's clear to you. I'm taking this question as per format. You have to solve this question in this way. First of all, you have to take two positive integers. There is one more thing here, that you have to take your b as 6 now. यहाँ आप देख रहे हैं बी क्यू प्लस आर, बी की वैल्यू 6 है. So let a be any positive integer and b is equal to 6. A be any positive integer and value of divisor is 6. The quotient will appear as q and remainder can have these 6 different values. Applying Euclid's division lemma, can you write this a in form of Euclid division lemma? Certainly yes. What will this a be? A is equal to 6 multiplied by q plus r, where value of r is this set, any one of this set. इस सेट में से r की कोई वैल्यू हो सकती है. So a is equal to 6q plus r here. Write your condition where r is greater than or equal to 0. It will be your condition. Then a can have 6 different values. What will be the first value of a? I am taking a can have value of 6q when you take remainder 0. Now I am taking this value of r. I am taking r as 1. Then what will be value of a? 6q plus 1. If I repeat this process by taking value of remainder equal to 2, then it will become 6q plus 2 and so on. 6q plus 3, 6q plus 4 and 6q plus 5. Can it have value of 6q plus 6? Obviously not. There is no possibility of 6 here. So don't write this next term. 6q plus 6 should not be written here. There is a restriction. इसको आप नहीं लिखेंगे क्योंकि r की वैल्यू 6 नहीं हो सकती. क्लियर यदि हो गया हो तो मैं आगे और बढ़ जाऊं. Now look at these numbers. I'm selecting some of these. 6q, 6q plus 2, 6q plus 4. All these three numbers are divisible by 2. In the same way, as I have taken in previous question, I have values of a. First value of a is 6q, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4, and 6 cube plus 5. Remember it. If our divisor is 6, then A can have 6 different forms. If I take remainder 0, it will appear as 6 cube. If value of remainder is 1, then it can be written in form of 6 cube plus 1 and so on. I have selected these numbers already. Look at these three forms now. Now 6 cube plus 2 and 6 cube plus 4 are divisible by 2. Therefore, these are even numbers, as positive integers can either be even or odd. Therefore, I am writing one more line here, as positive integers can either be even or odd. There is no third possibility. Therefore, the remaining forms of forms are odd. And what are remaining forms? Check them out. The numbers enclosed in yellow boxes are remaining. So you have to write them down here. Therefore, 6 cube plus 1, 6 cube plus 3, and 6 cube plus 5 are odd numbers. I think this process is now clear to all of you. I'm taking some more forms. Now I need some basic concepts to devise. How to write squares. In next question, we have to apply Euclid's division lemma to show that square of any positive integer. Any positive integer. What is the meaning of this any positive integer? Remember, in question 1, I have two forms. First form was 2 cube and second form was 2 cube plus 1. In second question, when I have taken value of b equal to 4, then the forms were 4 cube plus 1, 4 cube plus 2, and 4 cube plus 3. And I think now in this previous question, when I take b equal to 6, there were 6 different forms. 6 cube plus 1, 6 cube plus 2, 6 cube plus 3, 6 cube plus 4, 6 cube plus 5. Then any positive integer can have these 6 different forms. Now let's have some more interesting aspect of these 3. This 3 स्क्वायर में ये 3 आना है, तो I have to take b equal to 3. In earlier cases I have taken b as 2, b as 4 and b as 6. Now I will try these numbers by taking b is equal to 3, and I have to expand the squares. Do you know how to expand squares of binomials? If yes, it will be clear to you, and if no, then try out some questions. Let's have some more questions. There is a possibility that you have to expand squares depending on your formulae studied in 8th or 9th class. How to expand squares? Suppose in one question the form was 2q plus 1, and I have to find out the square. Then you have to apply your a plus b whole square formula, and it should be square of a means first term, square of b second term, and sum plus 2 times the product of these two numbers, 2 multiplied by 2q into 1. Do you know the formula? A plus b square is equal to square of a plus square of b plus 2 times the product of both the number. I am using this formula. Sometimes students forget to use this term. If you are not writing this term, your question is completely wrong. So first of all, you have to learn how to expand squares of binomials. I am taking 1 or 2 more examples. Here I will write b as 3. So what will be the possible forms? If I am taking a as 3q, 3q plus 1 and 3q plus 2 form. Remember, if I take b as 3, r can have value of 0, 1 and 2. So a can have 3 different values. It's so easy to write the square of this number as it is monomial. What will be the value of a square? Square of this number, 3q whole square. Next number, 3q plus 1 whole square, 3q plus 2 whole square. Now you have to expand these expressions using formulae. How to expand these numbers? Let's try. Learn these expansions by heart. I am trying one for you. 3q plus 1 whole square is equal to the same pattern. I am taking this number as a and this number as b. So it will be 3q square plus square of 1 plus twice the product of both the numbers. Now simplify this expression. It will be 9q square plus 1 plus what will be the product of numerals 6 and variables q 6q. So in standard form it will be 9q square plus 6q plus 1. Can you expand this square? If yes, let's try our next question. And if no, then take some questions from 9th and try to learn expansion of these squares first. यदि आपको ये एक्सपेंशन नहीं आएंगे तो आप ये क्वेश्चन नहीं कर पाएंगे. सिंपली पहले ये स्टेप आपको सीखना पड़ेगा. मैंने कोशिश की है एक दो, और ज़रूरत पड़ी तो अगले वीडियोस में और दिखाऊंगा. Now let's solve this question. We have to show that square of any positive integer either of the form 3m or 3m plus 1 for some integer m. I will take this m later on. From the very beginning I am taking q and b as 3 and a is some positive integer. So how to start? Let's try. I need some space. Whether this question is clear to you, I am taking separate sheet. Let a be some positive integer, any integer you can write, and b is equal to 3. Then we have three different ways to express a using Euclid's division lemma. Sorry, चार्जिंग ऑन कर देता हूँ. Sorry for interruption. Using Euclid's division lemma, I think this Euclid's division lemma is now clear to all of you. If not, then watch previous video once again. Can you write a? I am writing this Euclid's division lemma in full form. A is equal to b multiplied by q plus remainder r. What was the condition? R is greater than or equal to 0 and less than b. So from very beginning, can you substitute a? No. It is some number, can have any value. Can you substitute b? Yes, I have taken b as 3. Q is also variable here. Can you replace r? Yes, of course. If b is 3, then value of b is given in hidden form. How can you find out? R can have value 0, 1 and 2. So I am replacing this value from 0. It will be the first form. A can have one more form, 3q plus 1. A can have one more form, 3q plus 2. Had I taken this B5, then you have to write 5 different values here. If value of B is 2, you have to write out 2 different forms. Remember this. Forms of A depend on B. How many forms are there of A? Now, we can write A in form of 3 different forms, taking 3 different values of R. Is it clear? Then, here A can have 3 values now. A is either of the form 3q, 3q plus 1 and 3q plus 2. Let's come to next point. I haven't written square so far. I'm taking positive integers. This positive integer A can be written in 3 different forms, and these different forms are shown here. One form is 3q, other is 3q plus 1, other is 3q plus 2. Then what should be the value of A square? A square is 3q square or 3q plus 1 square or 3q plus 2 square. Simply I have written down the squares of these forms. Now I have to expand these. Case 1, when value of A is 3q square. Let's take when A is equal to 3q, then A square is 9q square. I can write this number as a multiple of 3 as it is divisible by 3. So I can write this 9 into 2 terms. 3 multiplied by 3q square. If I am taking this number some separate number, this is some integer, I can write this form once again as 3 into m. Specify here if m is equal to 3q square. Then a square, any square of any positive integer, can either be of the form 3m. What's about second option? Let's see. I'm taking second option when a is 3q plus 1 whole square. When a is equal to 3q plus 1, then a square will be square of this number, and I have taught you how to find out square of this number. If yes, I write down it directly. It will be 9q square plus 6q plus 1. I have taught you earlier how to find out square of this number. Try it out. If no, kindly reverse this video and see the previous activity. Now, what is this number? I can write this expression as a multiple of 3. This expression can be written as 3 into take 3 as common factor, 3q square plus 2q plus 1. I am substituting this value now. This 3 is the same. I am taking this value as m. Remember, it will be some positive integer. If I am taking q as 1, the number will be 5. If I take q as 2, then it will be 17, I think. If I am taking q as 2, 4, 3 is 12, 16, plus 1, 7, 16. 3 की टेबल में ये हो जाएगा 33. You can try it out. It's a series. It will provide you a certain number. Plus 1. What is this form? This form is 3m plus 1. You have to mention here where value of m is 3q square plus 2q. I have enclosed this value in box. This total number has been given a unique value of m. Clear? You have to substitute this value here. So this number can be of the form 3m plus 1. Let's try third type. When a is equal to, this is third option, 3q plus 2. Then what will be the value of a square? Can you expand this square? If yes, then I am writing down the value of this number 9q square plus 12q plus 4. Can you find out some multiple 3 here? Obviously, these two numbers have 3 as a factor. But it seems 4 is not divisible by 3. Then try to split this number into 2 different numbers. 9q square plus 12q plus 3 plus 1. Remember this. This number has a common factor 3. And I am using this box now, which will be later on substituted by m. Taking 3 as common factor, 3q square plus 4q plus 1. and plus 1 again. If I'm taking this value as m, I can write this value into 3 multiplied by some number m plus 1, where m is equal to, क्या थी m की वैल्यू, लिख दीजिए इस बॉक्स को, 3q square plus 4q plus 1. So what we have done so far, I have shown you in 3 different cases that a can be written in form of 3m plus a square, a square can be written in form of 3m plus 1 only. Square of any positive integer can either of the form 3m plus 1 or 3m. Case number 1, where you have taken value of a as 3q, 9q square को हमने ये फॉर्म दी थी, केस 1 है ये केस 2 और 3 दोनों में हमने शो किया कि स्क्वायर ऑफ 2q plus 1 and 2q plus 3q plus 2 और 3q plus 1 की फॉर्म आई थी 3m plus 1 square. I think you can do these questions yourself. The length of video has become too long, so next selected question will be taken in next video, and if you want to try it yourself, you can try it as your homework. So let's try these questions once again, sitting inside your room, and if you find out some difficulty, you can watch this video once again. Do not copy your homework from this video. You have to learn how to solve these type of questions yourself. So it's taking too long time for today's lesson. I'm summing it up. Stay fit. Keep yourself and your family healthy. And I'm missing you badly and your responses. Thank you very much for watching this.